a PhD student at the University of Cincinnati. And I'm going to talk to you today about testing competition hypotheses in Darwin's Finches. So I'm going to test some old ideas with new data. Let's see what you guys think about it. So, Darwin's Finches, this is an evolution conference, most of you know the drill. They're the textbook example of adaptive radiation. These birds are endemic to the Galapagos Islands. There's about 18 species of them. And they diverge in a short amount of time. And morphologically, what's most distinct of these guys is the shape of their beaks, which has been linked over and over to what they eat. The two groups that I'm going to be talking today of finches are the ground finches and the tree finches. There's another group that's more basal over there. Those are the warbler finches, but I'm not going to study those. So ground finches eat seeds. They use their beaks to crack them. Larger beaks crack larger seeds. And the tree finches are insectivores, and they also eat tiny bits of plants. So because there's so many of these guys, and because these guys coexist in nature, there's always the question of how did this happen. And there's a lot of story about isolation, allopatric speciation, but because they live in communities with many species of Darwin's finches, I want to test what happens with competition. So the main hypothesis that I'm testing is character displacement, which is defined as differences among similar species whose distributions overlap, and then these differences are accentuated in sympatry, and in allopatry they're not accentuated. So ideally, to test this, you will have to get an experiment when you can have situations when you have competing birds together in sympatry, and then the same species in allopatry, which is hard to do for natural systems in the wild, but the Galapagos works as a natural laboratory. So what I've shown here in this map is the distribution of two of the finches that I'm going to talk about, the large ground finch and the medium ground finch. There are some islands, like those islands in the north. I think I have a lizard right here. Like those ones over here and this one, that only have the large ground finch without the medium ground finch. Other islands have only the medium ground finch without the large ground finch, and then there's these islands in the middle that have both of them in sympatry. So we want to test if when they are together in the same island, they're more different to each other than when they're not. That hypothesis would look like this. If you have your large ground finch up north without the medium ground finch, it should stay the same. But in the medium islands, the larger should grow bigger to avoid competition with the medium finch, and or the medium finch should shrink in the presence of the large ground finch. This hypothesis was actually observed in the wild in a classic paper by the Grants in 2006, where they saw that indeed, in this small island, there was a population of the medium ground finch. Then this island got colonized by the large ground finch, and then the medium ground finch shrunk. It was smaller. What I wanted to ask is if this process that they saw is pervasive. Does that happen everywhere? And then you will be asking, haven't people done this before? There's a lot of work with the Darwin's finches and their shape of their beaks. But the method that I'm using is this new method of geometric morphometrics, which contrasts traditional morphometrics, which is what most of the literature on Darwin's finches is based on. So traditional morphometrics is just a series of linear measurements that will give you a good idea of size, but not really shape. So what I'm doing is I'm putting landmarks in the beaks of the birds and comparing the geometry of these beaks. Another good thing about this is that you can compare size and shape independently using geometric morphometrics. This is the samples that we did. We analyzed 484 individuals for 4 species, 17 islands, 2 species of ground finches, 3 species of tree finches. And next, I'm going to talk about the results, and I'm going to talk first about the ground finches, then about the tree finches, for shape and size independently. So remember, what we're predicting is if they compete, then they should be different in sympatry. These are the results for the ground finches. The purple is the medium ground finch, the pink is the large one. And on your left, you have the result for shape, and this is the results for size. So let's look at size first. The medium ground finch is smaller than the large one, but when we compare populations of the medium ground finch in allopatry versus populations in sympatry, they have the same size. So this result is strikingly contrasting the classical results of the grants that say that the ground finch shrinks in the presence of the large one. There's also no character displacement for shape. So all the specimens in allopatry for each species are very similar to those in sympatry. There's no separation between X's and dots in this graph, which means no character displacement for these guys. For the tree finches, the situation is a little bit more complex because we suspect that more species compete with one another. And then what we have here is three species, small, large, and woodpecker finch. Again, let's look at the size. The woodpecker finch is the largest one. It's not different when it's with competitors. For the small tree finch, when populations of the small tree finch have the large tree finch in their community, they become smaller, which is a good hint of character displacement. And the large tree finch becomes smaller when the woodpecker finch is in its community. So there seems to be a hint at character displacement in size for the tree finches, not the ground finches. And then talking about shape only, we can see a trend. The way we coded things here is populations with high competition or low competition, as opposed to sympatry or allopatry, because we have main species. And the lines of these triangles, the dotted line indicates distances of the centroids of populations in high competition. I mean in low competition. So in low competition, they look more like each other. These thicker lines are populations in high competition, so they tend to occupy more morpho space. They're more dissimilar to each other. And I have to underline that even though I really like these results because they show the character displacement for shape, the way we've been testing this, we haven't found significant differences. So there's like a trend, but not significant. So for conclusions, large ground finch and medium ground finch don't display character displacement in shape or size. Again, this is important because it doesn't contradict, but it contrasts this classical study of character displacement by the grants observed in one island in the Galapagos. The small tree finch shrinks in the presence of the large one. The large tree finch shrinks in the presence of the woodpecker finch. And the tree finches diverge in morphospace in high competition, but these results are not significant. And I think I did it too fast because there's no. So, do you guys have questions? Maybe we can. Yes.
If you were to do the linear measures that the grants did, do you have an idea of whether or not your results would be different, especially for the ground finches? So I know you use centroid size, but that's different from like beak depth or width or something.
Yeah. So I would have to go back and remeasure these birds because I don't have that data right now.
So could some of your landmarks be used to get an estimate of like upper beak depth?
Yeah, I mean, I can have the depth and width because I took this from like proper pictures, but the width's going to be hard to.
Because that could be an interesting contrast to see if using those measures you find or don't.
Right, that's a good idea. Sorry, there was a question here first.
Sorry?
Thanks. Cool stuff. So why would you expect or why do you think there's a character displacement with the tree finches and not the ground finches, given that the tree finches are basically insectivores, or thought to be insectivores, and the ground finches, though, we know that the beaks are quite tied to the seeds and that sort of stuff. So why do you think this is going on?
With tree finches?
Yeah.
So this hypothesis was first proposed by David Lack in the 1940s, where he, doing his collections and his observations in the Galapagos, saw that populations of different tree finches in the presence of other tree finches were different. So he hypothesized that maybe it's because of competition. Some the feeding behaviors of the large and small tree finch are very similar, and their beaks are very similar, which is like differently in size. But then he saw that the woodpecker finch, which is like more pointy one, some populations of the large ground finch, tree finch, have pointier beaks when the woodpecker finch is not in the community. So that's what we wanted to tell.
They use
To us.
tools, do you know?
How?
Do you know if the large tree finches that are pointier use tools?
Yeah, that's the one that like grabs the twig and fishes out a larvae. Then for the other part of the question is why we didn't see character displacement in the ground finches, where like everybody talks about character displacement in the ground finches. One part of the answer is a lot of the story about character displacement is being told for, I wouldn't say anecdotal, but just like very limited in time and space observations. Like one island, this is what happened. One of the strengths of this study is that we have replication across islands with like a good experiment. But the other answer for that is that the ground finches, like many of these birds, but mostly the ground finches, there's extensive evidence that they hybridize between islands. So there's a lot of gene flow going from one island to another, and that might counteract the effects of selection, right? So you have like an in-between shape of ground finches everywhere. Yeah.
The measurements that you took were from museum specimens?
Yes, so all of these are from museum specimens.
So did you include the year as a covariate in your analysis? Because if there's some temporal dependency, it might be swamped if you treat all of the samples across all years the same. I don't know if it would give you more power to detect.
And unfortunately, because it's hard to get all of these specimens, I don't think I would have enough power to have like good sample sizes across time. But it's worth taking a look. Yes.
Do you think there might be an ecological explanation for why you're not seeing character displacement? Like, they have to be competing really strongly for character displacement to happen. So, maybe these specimens come from years where some other limiting factor was limiting the population, not competition for food.
Right, that's a good idea. Maybe all these species come from years that the resources were abundant and they just weren't able to, they didn't need to compete because everyone was fat and happy. But because we have samples from like many different years, we wanted to lump everything together to see if there's like a general trend, even though we know that most of selection happens in dry years.